on to iReady after you were done. It's recording in progress. All right, so you guys had to do these problems on your own. Okay, as a group, but on your own, right? And you didn't have anybody else to help you. So I want to take a few minutes and I want to go through them. So what you need to have at your desk right now is this. You all need your whiteboards. You all need your whiteboard markers. Okay? Because you're going to be working together on these problems one more time. And then you're going to share it with your group. And then you're going to share it with the class. We're going to help each other out with it. Okay? So, recording, here we go. Recording is started. All right, so after a few little hiccups, I think you guys started to figure out the relationship. So T, I'm picking on you first because your group hit it right away. And then I'm gonna go to Duncan because Duncan also got it. All right, so T, tell me what you can tell me about this.
You have to times 1/3 to every x, I guess.
So you took this X and
Yeah.
you multiplied it by 1/3, and what would you get?
1/3, I guess. Yeah.
So 1 times 1/3. Sorry, I can't see that. Wow. How about we go back? There we go. All right, let's try it. You know what? How can I just do this? There. All right. So 1 times 1/3 is 1/3, right? So what would that be? What would this be called? A constant? But in order to make sure that is the same over and over and over, what do we need to do here? Same thing we did. So what's 2 times 1/3?
2/3.
Oh, doctor! What's 3 times 1/3?
1.
What's 4 times 1/3? Sit up, you guys are too. Come on, let's go. Come on, up. Right there. Okay, all right. What's 5 times 1/3?
1 2/3.
Okay, all right. So now I'm gonna go to Duncan. Read what you said on yours. Damon, I'm sorry, Duncan. Hold on. I want Damon's answer first. Damon, tell us what you said.
I just said because 1 on x equals 1/3 on y.
Every time we multiplied 1/3 times x, it gave us our y. Okay, now, Duncan, all right, now Duncan also did this, okay? He sat there and we didn't even look at the equation. We were focusing on the table and he said, okay, well, 1 times 1/3 is 1/3, right? And so he said, so x times 1/3 equals the y value. And he wrote that. Eyes up here, you're something. Okay, he said x, well, he can't say it with an eraser. He said x times 1/3 equals y. And I said, oh my goodness. Look at that. Okay, now. So what you guys just found out, you looked at the table and said, the constant of proportionality is 1/3. Awesome. But how do we know that the equation shows the same thing? And I'm going to pick on Lila for a second because she did something super cool without even knowing it. Okay? What on her paper, I saw this. I saw 1 equals 1/3 times 3. Okay? All right? And if you look at this, what she did is she actually said, okay, y is 1. There's my y value. Okay, then I'm going to see 3. What's 1/3 times 3? 1/3 times 3, multiply it. Go. I have calculators. Do it.
1.
Oh, Stacy's like, I don't need a calculator. I got this. Okay, what's 1/3 times 3? Oh my gosh. That worked out, but Lila went even further. She did this. What was the other one that you had? Did you have the 2 and the 6? I thought you had the 2 and the 6 too. I thought you did. Yeah, right there, the 2 and the 6. So look at this. What's 1/3 of equals 2 here if we solve this. So it goes back to what Duncan said. For every 1/3 of x, it gives us our y. And remember what we talked about last week, which you probably don't, between the snow and the rain and the flooding. Last week was such a blur, but remember how we talked about in an equation? Where can you find, in an equation, where can you find the constant of proportionality?
The one. The one.
Well, where, in an equation, where can you find the constant of proportionality? It's given to you. Not everywhere. What? The number times the. Yeah, so look, everybody flip back to page 52. Page 52. So look at, okay? Look at number 4. Can I borrow this?
Yeah.
All right, T's got some good notes. So I'm gonna borrow T's book really quick. All right, look at this, okay? All right, right here, she found times 4. She found the constant of proportionality, right? So look at, describe the numbers. And then how long could she place? So the constant of proportionality was 4. And then look at her equation. Look at where the constant of proportionality is. Right there. All right. And it goes on further. Okay. Do you mind, T?
No, no, you're fine.
All right. Look at this one. Okay. Ooh, this is the one we really need to talk about too. All right. So the constant of proportionality is 2. And look at our equation. G equals 2m. Because we took the 2 times the number of minutes, and that's how many gallons we use. All right. And we'll have to come back and talk about page 53, number 1 in a little bit. All right. So I know that problem took maybe a little bit longer. And then sometimes you walk across things and go them. But the important thing that you guys need to realize is it's not about a pattern, it's about a relationship, proportional relationship. Now, the last thing that I want to talk to you guys about is this, and we don't know this, but we kind of do know this, right? You have 0, 0 here. Remember what I talked to you guys about how important 0, 0 is? Remember before winter break, we talked about that. What are 2 things that have to happen on a graph that show proportional relationships?
There's
What?
go to
And what's that? What's that called
the
on a graph? Or you're no what? The origin. What are the coordinates of the origin? 0, 0. Boom, shakalaka. Look at that. There's 0, 0 right there. And then it also has to be a what? Remember, on a graph, proportional relationships have 2 things that they have to do. Go through 0, 0, the origin, and it has to be a straight line, right? And the straight line comes from the constant of proportionality. We'll so talk about that in the next lesson. So it's okay if you were a little confused on that. Okay, so did everybody get an answer for this that you guys can go back and look at to study? Okay, so moving forward. Good job. I hope I'm recording this. Yep, I sure am. Okay, all right, here we go. Look at this one. Number 2, you guys had to do. Samuel says his sister's age is proportional to his brother's age. Is Samuel correct? With your group right now, you have 1 minute to discuss this. 1 minute to discuss this and assign one person that's going to share their answer. Ready, set, go.
Oh, you said with no. I said no. No, not even saying. If you time 5 times 2, it got 10. The second one would be 10 times 2 equals 20, which is not correct.
I haven't made it over to you guys. So can I help you guys? Yes, you're right. So what's the is a yes or a no. Thank you, thank you, thank you. Okay, thank you. And I already talked to you guys. Oh, why did you guys change your answer to? All right, okay, now, so now that we have Nada, but here's the big question. Shh, listen. It's super important that you guys have that, but why? All right, but why? So hold on, think about that for a second. Do you know who's going to talk for your group?
Yes.
Okay, pick somebody in your group that's going to be the sharer of all shareness. All right, Addie, you get to go first. Everybody, put your pencils down. Put the lid on your pens because we hate to compete with them. All right, Addie, what do you think? Oh, wait.
Start together, they wouldn't go through.
Oh, that's an interesting perspective. So you're saying that when the sister was 0, the brother wasn't 0. Oh, the brother would have been what, 5 years old, right? Interesting. Love that perspective. All right, who's talking for your group? Second?
It wouldn't work out because I always put back down to 1/2.
Oh, that's how good that one was. All right, I love it. All right, what did you guys say? We're going to combine all these together when we were at Amsterdam. Who's talking for your group? Lila. So what are you saying? You're saying what happens? Okay, it's not the same, but what's not the same? Oh, did you guys hear that in the background? Will you turn around and tell them? You tell them, that'd be great. All right, that's what you guys got too, right? Okay, so I will pick on you to go. Did you guys have something different than any of three of these groups? All right, so you guys, amazing job. First of all, I absolutely love you guys, your answer back there. Okay, that was very good perspective. Is that when the sister's age is 0, the brother's age would be 5. And it would need to be 0. That's kind of cool. All right, but up here, the constant changed. 5 times 2 is 10. But 10 times 2 is 20, not 15. All right, but Duncan's was super duper duper cool. Hey, are you guys paying attention? Okay, so this Duncan did this. He wrote these out as a ratio. Have a ratio. There's an you guys probably need to dance for this thing. You guys want to dance?
Oh, yeah.
Come on, you can do it. Ready? Ratio. Here we go. Ready? Guys, remember, ready? You guys need to stand up, or you want
Yeah,
to
we need to stand up.
Cole wants to stand. Let's go. Come on. Here we
Okay,
go.
I'll stand
A
up.
ratio.
I do this dance?
Oh yeah, it's super fun.
I forgot.
Okay, ready? Here we go. A ratio. Come on, Jordan, you can do this.
I'm so.
I'm out of my
Hey, you know what? Even if just stand up, kind of fun. Ready? Ratio. Comparison of 2 quantities by. This is the best part. Ready? By division. Right? Now unit rate though. Ready? Comparison of 2 quantities by division. Logan's like, you know what? I do MMA. I don't dance. All right. Okay. Yeah. So there it is. So what Duncan did was so cool. Because in order for you to have proportional relationships, you have to have equivalent ratios. So he said 5/10 is 1/2. 10/15 is 2/3. 1/2 does not equal 2/3. So that was awesome. I love it. Love it. Love it. Love it some more. Okay. So you guys have any questions on number 2? Are you guys understanding that you guys are looking for the relationship between the two quantities, not the pattern? All right, moving forward then. Here we go. Problem number 3. This one should fairly be a fast one. Okay. Explain what the circle ratio on this double number line means. Well, let's talk about the double number line first. So pages read is, this is the top stuff. The minutes of reading is the bottom stuff. So here's what this means. Oh, you know what? I'm going to stop there. I just want to go through and share that with you. What does it mean to you? You have 1 minute to compare your answer and pick one person that's going to share. Go.
Because we got the same exact thing. I need to help you. Oh.
You guys are going to have to relive this. So the model that we came up with looked like this. All right, so we have keychains. You know what? Hold on, I'm not going to make you guys sit through this. I'll do this on my own in a second. So what I want you to do, you guys have 2 minutes. That's it. Can you go through and find out how many feet of cotton cord she's going to need for 5 keychains? Go. Not yet, just a minute. Okay, 5, 4, 3, 2, 1. Okay, I don't want to know the answer. I don't want the answer. I want to know the process.
Oh.
So what did you do to find the amount of cord needed for 5 keychains? All right. Oh, I haven't heard from you today, Andrew. Did anybody do anything different than that? All right. So now, with that being said, what's our answer? What is it?
1/3.
Okay, repeating. All right. Good, 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 good. All right. So